Okay, it's that time again. It's Tuesday. It's 1 o'clock Central Time, and we are back with our HDF clinic. I checked earlier; there weren't any questions, but let me just check again. No, there aren't any questions, at least in our Google sign-up sheet. But I'm going to pause, and for those who are attending here today, are there any questions about HDF5, your applications using HDF5? Anything? I'll pause many more times, but maybe I should. Yeah, I'll do it right now. Any questions? No? Okay, good. Then I'll just continue with our usual walk around. Um, I have not found the answer to that question. Last week was also rather busy, and we'll talk about last week a lot. That's most of today's content. We had our European Hug event last week on Wednesday and Thursday, and it was great. I mean, I was there. I think there was some great content, and the good news is, if you didn't get up that early, so that was in Europe. So the days were structured that the meetings started at 7 o'clock in the morning Central Time. So I believe that was 2 o'clock in the afternoon European time, Central European time. And then I think it went until 11 o'clock Central Time here, so for 4 hours. And it was great. I mean, I enjoyed all the presentations, very novel, high quality content. I mean, everybody did, I think, did a spectacular job presenting their research, their projects, and so forth. And the good news is, I linked it here. The playlist is up on YouTube, on our YouTube channel now, and I encourage you to go there. It's nicely, it's not one or two gigantic binge watch movies. It's really nicely broken up into individual talks, so you can really just pick and choose, go there and watch the talks were typically 15-20 minutes with 5-minute discussion. So it's nicely broken out that way. And yeah, we'll come back to that, but it's definitely great watching for anybody, because it talks about very call it modern topics, virtual object layers, swimmer VFD, and then yeah, how people use HDF5 in production at these. It was hosted by the European Synchrotron Radiation Facility, ESRF, and Grenoble, and of course they showed how they use HDF5, but also all the other presenters from large European research facilities showed how they use HDF5 and so forth, and it was really I really enjoyed it. Announcements at the moment, the only pending announcement, so to speak, is still that as we just had that European Hug event, there will be sort of a Hug event for the Americas in October, and the call for papers and presentations is still out there. Deadline is August 1st, so you have another 2 weeks, a little over 2 weeks. So please join in, and I'm sure this is also going to be another great event. It's going to be more civil time-wise for people in the Americas, but yeah, it'll be a lot of fun. I will pause here before I talk about what came up in the forum, and just ask again, does anybody have a question about HDF5, about these events or things they heard in case they were able to attend? And no? Okay, then I'll just continue. And I think quite a few posts that we saw on the forum were sort of related or picked up on things that attendees saw at the Hug event, and they just saw something, they saw somebody using HSDS or something, And then they thought, I should try that. That looks interesting. I want to try that with my application or in my setup. And then they went out and in some cases ran into some issues and so forth. But then I think we see some of the fallout on the forum. And that's good to see, is really that people were inspired by that event. And there was sort of, if you look at sort of the average weekly post frequency, there was definitely an uptick. So that was the European Hub 2021 boost, I think, that we are seeing on the forum right now. And I'm sure it will fizz out at some point, but nevertheless, it was interesting to see how many people sort of picked up on themes that came up during that meeting. Okay, here's the first one. This is a question about sort of lack of clarity or inaccuracies in the file format specification. And this picks up on a theme. One of the themes at the HUG event was to talk about accessing HDF5 files directly without using the HDF5 library. And that's not a novel idea. And in fact, I think that's part of the strengths of HDF5 is we have a published specification. It's openly documented and published. And the HDF5 library that we distribute is, in a way, call it the reference or a reference implementation of how to manage the contents in files that are formatted in accordance with that file format specification. And then in some cases, people might require a lot less. They have maybe HDF5 files that contain only a certain type of content. So they might say, well, the HDF5 library is just this big thing. I can get away with a lot less. I can maybe write a Python script, or depending in which environment they use it, I can just sort of go into that file directly and pick out the bits and pieces that I want. And that's perfectly legitimate. And we saw in the past, we have seen several examples. For example, there was an effort in Python here, this called Py5. I linked the GitHub repository, I think up at Argonne National Lab. Somebody did that, implemented a pure Python HDF5 reader that does not use H5Py. It does not use the HDF5 library and so forth, just uses the HDF5 file format specification to read bits and pieces. And in the past, I remember there were efforts in JavaScript, for example, using the Node framework. There are efforts in, and we've talked about that in the past, in .NET. Somebody implemented a reader and writer, or is in the process of implementing reader and writer in .NET, completely independent of the HDF5 library, so purely what one might call managed code in .NET. And there were a few others, but sort of Node, JavaScript, Python, .NET, all sort of the things that are fresh in my memory. And at last week's event, a researcher from NASA, Joe, I forgot his first name, Swinsky, presented a small library that he implemented in C++, again, going back to the file format specification directly, not using the HDF5 library to access HDF5 files that are stored in the cloud, in his case, in an object store in S3 on AWS, and then to just parallelize the access to these files. And he got very good performance with his independent framework. It doesn't use HSDS, it doesn't use any of those other technologies. And so it's called H5 Coro, So if you go to the YouTube playlist and look for H5 Coro, you should pick up his presentation, which I highly recommend you watch because he talks about what kind of effort it was and what kind of performance he got. So long story short, there's always, this is a good opportunity to see how clear our specification is, in the sense, are there ambiguities, misunderstandings, and so forth. And here this specific question was about heap identifiers and so forth. And if you go to that thread, Neil Fortner replied to this gentleman, and I believe he made it very clear how this heap ID business works. And yes, there's always room for improvement of clarifying the specification and so forth, and we'll keep improving it as we encounter, as users out there encounter, developers out there encounter sort of these situations where they are not 100% sure how to interpret the specification, and everybody will win in the end. So that's good. So that was one. Next, I think this was also inspired by, there was a lot of talk about HSDS. John Reedy gave a great update on where the HSDS development stands and where it's going. Among other things, he announced, for example, it used to be available only on AWS with S3, but now there is a port available in the Microsoft Azure cloud, so you can run HSDS on Azure, but then also you can run it pretty much if you have a Kubernetes cluster and a storage backend that has an S3 compatible interface. Then you can set up HSDS, and I think we have another example in just a moment. But here, this question was, somebody was asking about how to build the REST wall on Windows 10. So just in case you are not familiar with that, HSDS, if you wish, is like accessing HDF5 through a RESTful, through a service-oriented interface. And so you're basically, typically that's implemented using HTTP primitives such as put and get and post and so forth. And of course, for compatibility purposes, we would like, if you have an existing application in C or Fortran or something like that, and you would like to access HDF5 content stored behind an HSDS service endpoint, we would like to make that process as seamless as possible for you to access that data without changing your application. And that's exactly what the purpose of this REST wall, this REST virtual object layer interface is, or plugin is. And what that does is, at the end of the day, it basically, when you do an H5D write, for example, well, under the covers, it basically converts this using a libcurl. In this case, libcurl is sort of a library interface that you can use to interact with HTTP protocol-based web services. It basically translates that H5D write, or for that matter, any other HDF5 call, into a sequence of RESTful requests. So whatever that might be, put, post, gets, and whatnot. And so your application is completely oblivious that it's actually not talking to a local file system, but rather to an HSDS endpoint that's hosted somewhere in a cloud or on-premise in a cloud interface. And that's fine. I mean, there will be obviously performance differences because this is typically a very latency sensitive arrangement and so forth. But the primary purpose of this is really sort of compatibility or legacy, if you want to call it that. And then, yeah, on Windows, there's always a little extra since the build process is a little different on Windows, the user had some linker errors and so forth. But I think that he in the end was successful in building it. And so that's a good story. And again, I think as part of this HUG event, there was a lot of interest in cloud and HSDS, sort of cloud-based, service-based HDF5, and that triggered that people thought, man, I wish I could use that from my application with my application on the Windows platform. And people just went out and tried it. And okay, we helped them over the hump and got it going in the end. Next, there was a question about file storage on AWS. Again, sticking with the cloud theme, I think there are a few more questions with the cloud theme. And again, all goes back to HUG. Somebody had a question about how is the data actually stored when an HSDS endpoint sort of serves HDF5 content. How is that HDF5 content really represented? For example, in AWS 3 or in any other sort of object store that has an S3 compatible interface, which most of them do nowadays. And so there is, I linked here the specification. The trick is basically, there is typically a bucket because what the user found and what John pointed out in his presentation is there are all these different JSON objects, and they are sort of in the, call it the top level bucket or directory in double quotes. But then the user was asking, well, where are actually the chunks? So for example, you have a data set and these data sets are represented in chunks, and each chunk is its own S3 object. Where are those objects? And John pointed out basically that there is a DB, I'm going to call it a folder, but it's really, there's one bucket, and then these objects, you can mimic a folder hierarchy in double quotes by just naming the object with slashes in the name and so forth. So there's a DB folder in there, and then the chunks are actually stored in there, and then the specific structure of those objects, of those chunks, is described in John's specification here. So there's the link to GitHub. Another interesting question, and again in the same vein, somebody is saying, okay, I'm in a local setup, they're using pandas, which is sort of very popular framework, obviously, and with local files and so forth. And now they would like to make the migration or attempt a migration to HSDS. And then the question is, well, what happens? And interesting in this case was also that, yeah, AWS 3 is certainly popular, but there are other fine choices and popular options. So for example, as an alternative, there is a hoster or a provider called DigitalOcean, and they also offer storage in terms of so-called DigitalOcean spaces that have a S3 compatible interface. And then he was able to make HSDS work on top of that. And I think John has pretty good documentation describing that. But then on the client side, the user is using pandas. And the question was, well, how do I access HDF5 files that were generated from pandas in this setup? And will that work? And John hasn't posted an answer yet, but I'm sure he's thinking about. I think there are sort of two different modes here. One is, of course, taking a step back, we know that pandas uses the PyTables format, the sort of the PyTables, let me call it the profile, not the format, because the underlying format is, of course, HDF5. So pandas, HDF5 files generated from pandas use this PyTables profile to represent the data frames and all these things in that HDF5 file. And of course, if that HDF5 file is just stored as a blob, then of course it's the same blob that otherwise would be stored in the local POSIX file systems. But if it's broken up into, if the data sets, for example, that are there in this PyTables file, so to speak, are broken up into chunks and so forth, then of course that's fine and actually completely transparent to pandas. But the missing link then is, since pandas internally uses PyTables to access these HDF5 files, to my knowledge, there is no, like with the REST wall as we saw earlier, there is no translation layer that translates sort of PyTables calls into RESTful calls to HSDS, and that could be the stumbling block. And unlike H5Py, where John provided this H5PyD module that is sort of compatible with the H5Py interface, so instead of using H5Py, you would say using H5PyD as H5Py, no other changes to your code, and that would just work. In the case of pandas, that does not work. Now, if John has plans to support, obviously pandas is a very popular application. If John has plans to support that, I don't know, and you should wait, or let's wait until he replies to this question, and so we'll have some clarity there. But at this point, yeah, I'm not sure if that's going to work as seamless as it would with H5Py. And so let's wait and see here, but definitely an interesting question and use case. Then another interesting question was, someone was asking, was comparing, okay, again, they installed HSDS on their local system, and they were just comparing the performance between accessing HDF5 files stored in a local file system with sort of ingesting, so to speak, those HDF5 files into the HSDS instance running locally. And they observed a sort of, at least for reads, a 10x slowdown, and were wondering, well, is this to be expected? Well, yeah, I would say that a slowdown is probably should be expected. For one, of course, this is kind of an artificial setup, because if you're running HSDS on a local setup, there isn't really much point in it. Why do it if you can access your files directly on a local file system? Why would you create an artificial service layer in between? It could be for, I mean, you might say, well, I want a uniform interface, and it should be seamless to my users, whether they are accessing HDF5 content that sort of is stored locally versus content that's stored somewhere else. That's a legitimate reason. But nevertheless, in this particular setup, a slowdown is to be expected because, well, for one, in his response, John was mentioning he did some experiments on his local system and then also posted some figures that he noticed that the compression was actually pretty slow, and that's kind of known and not specific to this setup. It's just the software-based gzip compression in sort of standard implementations is very inefficient, or doesn't really utilize the available throughput bandwidth very well. But then, of course, because there is Kubernetes involved, you have a lot of inter-process communication going on. All of this overhead is just not there with the native HDF5 library, where you're just doing POSIX reads and writes. And so, yeah, I would say it's not unusual, or this is what I would expect, that definitely in a purely local setup, there will be some overhead, but also John commented that he is working on a more comprehensive performance test suite to sort of keep an eye on that and give people sort of better upfront information. Then again, I think lots of these, I can see them really coming out sort of out of people who just, did interesting new things inspired by the HUG workshop. They heard a lot about virtual object layer interfaces, and there were different examples mentioned and shown at the event. And rightfully, somebody asked the question, well, is there a list somewhere of all these virtual object layer plugins, and is there a list maintained? And yeah, we posted here a link. I believe I have it open in a web browser somewhere. I don't, but I will just jump right here. So there is a little bit of a website, like there is for when you register a compression filter, you obtain a unique ID to identify your compression filter. There's a similar table for that. That's here, the registered filter plugins. But likewise, there is one for these virtual object layer plugins, and it will probably grow over time. And so that's out there. And then, okay, there was another post somebody had asked about a month ago about an option when you run H5diff to tell H5diff, the tool, to ignore attributes, to not take attributes into consideration when comparing two objects, let's say two data sets or something like that, or two groups. And there is, Alan commented that in the develop branch, there is now a modified version of H5diff that introduces a new command line option called exclude attribute that has that desired effect. And finally, let me mention that we still have that thread open in preparation for the HUG event in October, where we are trying to collect sort of small improvements, if you wish, to HDF5 that are very important to users. And yeah, I encourage you to go there and add your wish or your use case to that. Now, we are almost out of time. I wanted to show you something about documentation, some of the activities there. This is, we have this docs.hdfgroup.org/HDF5 and so forth. I'm using here the S3-based URL directly, because sometimes when you update the documentation, it takes quite a bit of time for caches downstream to sort of pick up these changes. So that's why I'm going straight to S3 here, so that you can see that latest new content. We are working on two things at the moment. Well, we are working on many things, but two new things. One is we are thinking about providing some kind of cookbook for users. And what we mean by that is, and here are just sort of the beginnings, the layout, there will be sort of areas like files and attributes and accessibility and performance. And then within each of these chapters or categories, there will be, call them recipes, that will address specific questions. So recipes are there to answer questions, how to solve a specific problem. They are not open-ended. They don't give you all the background material. They are just, you have a task, and hopefully when you come to this cookbook, you will be able to find a topic, a recipe that looks very similar to your problem, and then you read it and then you have the right idea of how to modify that recipe for your purposes. So here are just some examples: tracking free space, creating an HDF, so HDF file user block. There will be a short, concise problem formulation. Then I'll work on that later this week. So there will be fully populated recipes later this week for these initial 5 examples, just to show the concept. There will be a solution, typically a code example, just the thing that's necessary to get this going. And then the discussion will provide, if there are sort of finer details or things to look out for or variants of the solution, that will be discussed here. And then references to related recipes. So that's one. And then the other one is they are kind of scattered all over the place. If you look at the current documentation arrangements, these RFC documents, yes, in some cases they are outdated, but they are sort of all over the place. And it's difficult if you ask, well, how many RFCs are there? Let me see all of them. That's very difficult to do. So our plan is to really have a page here where we basically have a table that lists all the RFC identifiers, which is typically the day, because it's very unlikely that there will be multiple RFCs on a given day. And then we will link sort of the up-to-date or the latest known version of the PDF for that. So here's one from 2014, and this is what it looks like, and you can go there. And yeah, in some cases, the material is outdated, but the good news is with these RFCs, they're typically, at the time, they were carefully prepared. They give you rationale around the design of certain features and so forth. So they are pretty valuable, even though they might be slightly out of date. You will sort of get the core idea and also some background information about how this was implemented and so forth. And so this is what's coming. And I'd be interested to know if both the cookbook and this type of an RFC collection, what people think. So if you have a comment, please post it on the forum. And I'm afraid we are out of time. Thanks for coming, and we'll be back next week, presumably. Thanks for coming, and yeah, see you next week.